All right, we're going to start now. All right, welcome back, everyone. Hopefully, you had a very good week. So before we get on to the slideshow, like our today's topic, going to take up. So Bob wanted to take up the last problem on last week's homework, where we talked about complex numbers. So is this problem right here, number 3? So there is a complex number z with imaginary part 164. So what this means is it has the term 164i inside it, and a positive integer n, such that this fraction, so z divided by z plus n, is equal to 4i. And the question asks for the value of n. And this is actually a problem on this, it's an American contest called the Amy. So you guys can search up, and you guys might want to try out yourselves too when you're in high school. It's pretty good, pretty fun contest. It's called the Amy, if you guys are curious. So I'm going to take this up on Google Canvas. All right, so we have a complex number z. Oh, who joined? Eric Lee. All right, hello, Eric. Let's check on the attendance. Hello. Okay, you're just missing one person. Perfect. Well, not perfect, but like almost perfect. Whatever. All right. Yeah, Eric, we're just taking up what we're doing. We're taking up this problem. Yeah, it was the last problem on the last week's homework for complex numbers. It was this. You can. Today, yeah, is the last lesson of the year. Yeah, it's kind of sad. And we'll be continuing in January. Next term starts in February, so you still have lots of time to register that. I'm not sure how it works. You can ask the principal, see how it works. Yeah. All right, and Jin 老师好, hello. Say hello to the principal. But okay, let's take up our problem. So if you had a chance to read it, Eric. But basically, so we have this complex number z, and it says that z has this imaginary part 164. So what this means, it has 164i in this term. But we have to, since it's part of the term z, like it's part of the z variable, that means that it also has a constant term, right? We know that complex numbers, they have this form a plus bi. So a is the constant term, like the real number term, and then b is the coefficient of the imaginary term, right? So we have this term a plus 164i, and well, the question asks for the value of a variable n, but let's try to solve for a first. We were also given this equation, so we had z divided by z plus n equals 4i. Sorry, 4i. That's what we were given. There we go. Okay. And since we know z is equal to like this format of a complex number, we can just substitute into here and see what we get from there. So substitute into these two values. So then on the top we have a plus 164i a plus 164i plus n equals 4i. Now right here, we want to get rid of the fraction. Usually you don't want fractions in the equation, so we'll just multiply both sides by this term right here. So we get rid of it on the left side. So we have a plus 164i equals 4i times a plus, I'm going to put n over here and then put 164i at the end. All right. Now let's expand the brackets actually. And we're going to expand it in the way that we have, it's going to look like this format. So like a plus bi. So what we can do is that we can make a plus n as its own term. So we're just multiplying 4i by a plus 4n. So we could do this. So 4i times a plus n. I'm not going to expand that, and I'll explain why. And we have 4i times 164i. I believe 4 times 164, that should give you, what do you think? So 656, I believe. Yep, 656 I squared, because there's two I terms. We multiply those together, right? But remember that I squared from our last week's lesson, I squared is equal to -1. Sorry, I can't write today. Okay, there, I squared is -1. So we just substitute this into here, right? I'm just gonna undo it so we save some lines. So remember, it was 656 times -1. So that would give you minus 656. All right, now what do we do here? Well, we realized, so the reason why I didn't decide to expand 4i times a plus n is because what I noticed that is that, so this term has an I, this term also has an I. A should be a real number, negative 656 should be a real number as well. So that means that some of these terms have to match with each other. So that means A matches with negative 656, 164i matches with 4i times a plus n. And so A, since A matches with negative 656, we get A is equal to negative 656. Now, it can't equal to this 4i term because we know that A is a real number and this is an imaginary number term. So they can't be equal to each other. So A has to match with the negative 656 term. So now that we have that, we have A equals negative 656. Now what we can do is we substitute A into this equation, this part right here. Oops. Okay, glitch out a little bit, but so now what we can do is substitute A into this part, and we can solve for n. And remember that we equated 164i to 4i times a plus n. So basically we had these two equations. So A is equal to negative 656, 164i equals 4i times a plus n. And let's get rid of the, I guess we can get rid of the 4i. Like, let's try to simplify this equation. And then after that, we can substitute a inside. So let's divide both sides by 4i. On the left side, you would get, so 164 divided by 4, that should give you 41. So 41 is equal to a plus n. So we divide both sides by 4i. And we get 41 is a plus n. And then from here, you can just substitute a right here to solve for n, like that. So 41 is equal to negative 656 plus n. And from here, you can just solve for n. You just add 656 to both sides. So that should give you n is equal to 697. And that is your final answer. Yeah, n is 697. So that's how you answer question number 3, like your last question on the homework. Any questions about that? I know this is like, I consider like a really challenging problem. Didn't expect all of you to, solve it. So yeah, I guess you'd call it like a bonus question on the homework. But any questions about it? And here we go back to our solution. Do you have any questions about the solution? Nope. No questions? Right. Okay. Now that we got that out of the way, we can move on to what we're going to do today. So just to end off the year of 2020. What we're going to do is just to solve some math contest problems. Not going to do a topic, not going to learn a new lesson or topic today. It's going to do a few math problems for fun. So let's get to it. So basically, I selected a few a few math contest problems from like past Gauss contests. So if you don't know what the Gauss math contest is, it's like this math. It's a grade 7-8 math contest that the CEMC, so this organization from the University of Waterloo, it's an it's an organization that helps host math and computing contests. So Gauss contest is just a grade 7-8 math contest hosted by them, and it's 25 multiple choice questions, and the time is 1 hour. So you get 1 hour to solve 25 multiple choice questions. And then for each of these questions, so for example, here's question one. I listed all the choices. You have A, B, C, D, E, and you just choose one of those choices. And here's the first problem. This is from the 2019 contest, and it's question number 7. So how many positive integers less than 100 are divisible by both 3 and 7? So if you have the answer, just unmute yourselves, or you can type in the chat. It should be fairly straightforward. Sorry? Can you repeat that? That's different, no. CIMC is it's a written solution contest, and you write in grade 9 and 10. They're completely different. But it's also part of the CEMC. Yeah. So don't get CEMC and CIMC mixed, because CIMC is the contest, CEMC is the organization. Yeah. The answer is 4, correct. Good job, Patrick. I'll show you guys why it's 4. Let's get a new drawing. All right. So we're trying to figure out how many integers less than 100 are divisible by 3 and 7. So I don't know. Let's write that 3 and 7. So if you want numbers that are divisible by 3 and 7, I mean, you could like write them down, obviously, but we can find a rule for that. Just to combine this into like one rule. So if a number is divisible by 3 and 7, that means it has to be divisible by 3 times 7. So 3 times 7, and that's 21. So a number that's divisible by both 3 and 7 has to be divisible by its lowest common multiple, actually. Is by its lowest common multiple, which is 21. 21 is obviously divisible by both 3 and both by 7. And so any multiples of 21 are also multiples of 3 and 7. And to figure out how many multiples of 21 are there, like under 100, you can just do 100 divided by 21 and basically just take the integer part of it. Like this will be a decimal of like 4 point something. I'm not sure what it is, but all you need is the integer part of it, which is 4. So therefore, there are 4 numbers under 100 that are divisible by 3 times 3 and 7, or divisible by 21. Any questions? No questions? Yeah, this question's pretty straightforward. Yep. I ordered these questions from easy difficulty to hard difficulty. So at the end, there's going to be more challenging problems. Let's move on to number 2. This is from 2020 contest, also question number 7. All right. Yvonne, I'm not sure how to pronounce that name. It's a weird name. Yvonne has 4 different notebooks and 5 different pens. He must bring exactly 1 notebook and exactly 1 pen to his class. How many different possible combinations of notebooks and pens could he bring? Yep, you said that, Patrick? That's correct. Nice. Oh, yeah, you can also type in the letter as well. So it looks like everyone typed C in the chat, so perfect. And the reason why is that, so if you remember from our combinatorics lesson, sorry, I'm on the canvas right now. If you remember from our combinatorics lesson, we learned something about the rule of product, where like you have like n different say like you have m different objects and then n different objects, and you want to, like a combination, just like one part of one item from m and one item from n, and the total number of combinations of that is just m times n, right? So I could do an example, like I could sorry, I could show like why this works, like using a diagram. So for notebooks and 5 pens, so I just drew each of those with a dot. So for each of the notebooks, I can connect it to 5 pens, right? So like that, like that's one of them. So each of them will have 5 lines. And so since there are 4 of these connections, sorry, like 4 notebooks and 5 connections for each, that means total number of connections would just be 4 times 5. And so that will leave you to 20 different combinations of notebooks and pens, right? Any questions about this? No questions? Right, let's move on. Right, here's 2020 contest. This is question number 10. Right, so Vita picks a number from 1 to 10. Balil adds 5 to this number and calls his result B. Callie subtracts 5 from Vita's number and calls her result C. The value of B minus C is what? Ten is correct. And yeah, Patrick, nice. Getting all these questions correct. You're a boss. Oh, looks like all of you said E. Nice. Right, let's share a tab. Let's try to solve this. Oh, they did? All right. That's okay. No worries about that. Not too concerned who gets it first. It's not a contest. Not like a time competition. Just as long as you get the answer right, you're good. But so let's solve this problem. So we pick a number from 1 to 10. Well, let's just call it x. We'll call this number that Vita picks x. So Balil adds 5 to this number, it calls it b. So his result is b. And this is equal to x plus 5. Yeah, you'll realize this is just simple algebra. Now Callie subtracts 5 from x and calls her result c. So we have c equal to 5 less than x, which is x minus 5. And so the value of b minus c is, we can just directly substitute these x values into b and c. And it's just very simple algebra. Or sorry, arithmetic. So x's cancel out. We have 5 minus -5, or just 5 plus 5. And that gives you 10. And what you realize is that like the number that Vita picks, sorry, the original number doesn't have to be between 1 and 10, right? X could be anything. Could be even be like a decimal, or even I don't know, it could be a complex number. Who knows? No, it probably can't be a complex number. Just any real number that Vita picks would work. So yeah. Any questions? Any questions about this? Nope. Yeah, so in the Gauss contest, so the first 10 questions, so from question 1, question 10, they put it as part A, so the easier problems. And then the next 10 questions, so from question number 11 to question 20, they call it part B, so like medium difficulty. And then question C is part C is 5 problems, so question 21 to question 25. And those are the most difficult problems on the contest. We'll get to those later in the slideshow. But let's move on to part B. So here we're on question 14 of 2018 contest. The number 2018 has exactly two divisors that are prime numbers. What's the sum of these two prime numbers? Should be fairly trivial problem. Yep, B is correct. B is 111. Right, get my point out. So that is the correct answer. And the reason why? Let's look at the prime factorization of 2018. All right, can someone tell me a factor of 2018? Like just any number that divides 2018 off the bat. 2. Yep. And 2 divided by 2018 is, sorry, 2018 divided by 2 will give you 109. And what you realize here is that, so if you try to find any factors of 109, you realize that this is actually a prime number. 109 is a prime number. You can't really divide this any further. And usually the way to prove that a prime number is prime is that first you take the square root of that number. I think this is around like 31 or something, somewhere around this number. And basically what you do to prove that 1009 is a prime number is that so you take all the numbers, all the integers from 1 to 301. Sorry, actually 2 and 331, because all numbers are divisible by 1. So you take each of the numbers from between 2 and 31. So like this number right here, the square root of 1009. And you try to divide it, see if it's divisible, if it is a factor of 1009. So I have to take 2, take 3, take 4, and determine if each of those are factors of 1009. And turns out that none of them are actually factors of 1009. So it means that 1009 is a prime number. And so the question is asking for the sum of the prime numbers. So it means you can just directly add these two. And that gives you 1011. Our final answer. Any questions? Oh yeah, and 2 is also a prime number, obviously. So that satisfied that as well. Any questions? Right. So these are the fairly simple problems. You can get into some harder ones. Right, here's a geometry one. In the diagram below, so this one on the bottom right, triangle QRS is an isosceles right angle triangle with side length QR equals side length SR. So these two side lengths are equal. And angle QRS, so this one right here, is equal to 90 degrees. We have line segment PT intersecting SQ, so this side length intersects SQ at point U, and side length SR at point V. Now, if angle PUQ, so this angle, is equal to angle RVT, this angle right here, and we will set them equal to a variable called y, find the value of y. Right, give you guys some time to type in or say out your answer. Anyone have an answer so far? Just curious. you said, Devin? Yeah. C is correct, 67.5. I'll show you guys why it's that. Why it's C. Oops. I'm just trying to redraw the diagram for you guys. But yeah, it's a really awful triangle, but whatever. It works. As long as it works, it's good. All right. So this angle is Y. This angle is also Y. I'll just put a degree sign as well. It's not the exponent 0. This is a degree sign. Yeah. We're also given that this is a right angle. These two side lengths are equal to each other. All right. And so what we're trying to do is solve for this value of Y. So what we need to do, first of all, is we want to find out the value of some other angles as well. Most importantly, I want this angle right here because it's closest to the Y values right here. Can someone tell me what this angle right here is equal to? This part. Yep, it's 45 degrees. And the reason why? So because you have an isosceles triangle, not only do you have two side lengths that are equal, you also have two angles that are equal, right? We're given that one of the angles is 9 degrees. And so then the two other angles have to be equal to each other. You can't have two 9-degree angles, otherwise you just get 180 degrees immediately, and you can't form a triangle with that. So it means the two other angles have to be equal to each other. So these two angles. You could just call it x. So we could do x plus 90 to get you 180. And then if you solve this algebraically, you get 2x is equal to 90. Divide both sides by 2 to get your 45-degree angle. All right, so now that angle right there is 45. Now what we can do right here, so let's take a closer look at this triangle right here, this part. Whoops, just about this part actually. So this section right here, we want to take a closer look at that. So if you realize something, you notice that these two angles, so these two angles are opposite angles right here. So this and this and this. So that where I drew my dots, sorry, just draw right here and draw right here. So those angles right there are opposite angles. So it means they're equal to each other. So let's draw out that part. So we had this. So this is 45. We had y right here. We had a y right here as well. Now, since these two are opposite to each other, that means this angle right here is also equal to y. Similar thing for this angle right here. This is also y because this angle is opposite to this angle right here. And now we have a triangle right here. And with this, we can form an equation. So it means that y plus 45 is equal to 180 degrees since they're in a triangle. And we can simplify this. 2y is equal to 180 minus 45 gives you 135. And y will be equal to, so 135 divided by 2, that's be a decimal. So 67.5. Y is equal to 67.5 degrees. That is your final answer. Any questions about this? No questions? All right, let's go back to the slideshow. Let's go to next question. Sorry, this one. On 2017 contest, question number 20. In the 6-digit number, 1 A, B, C, D, E, so each of those are a digit. Each letter represents a digit. Given that 1 A, B, C, D, E times 3 is equal to A, B, C, D, E, 1, find the value of A plus B plus C plus D plus E. I'm going to rewrite this on the canvas actually. so it's easier for you guys. So 1 A B C D E times 3. So we're going to write this in like a vertical multiplication format. Whoops. There you go. And this is equal to A, B, C, D, E 1, I guess. All right, there you go. So this is the question. I just reworded it right here. I'll give you guys a minute or so to figure out what A, B, C, E should equal to. Right, you know what? I think we're just going to take this up right now. So, well, you know, in the multiplication, we have to work from right to left. So we're going to first multiply E by 3 to get our digit 1 right here. So does anyone know what E should equal to? Yep, E is equal to 7. So 7 times 3 would give you 21, and you only take the last digit of that, which is 1. So that means I'm just going to replace this E with 7. And same thing for this E as well. So now we have the value of E. Now 7 times 3 is 21. And then that means we have to take the 2 over here. So that means we have D times E plus 2 gives you 7. I can just write this as an equation right here. So it's 3D plus 2. That looks like a 0. But that's D. 3 plus 2 gives you 7, like the last digit ends in 7. So someone tell me what D should be equal to. And can be only one thing. It has to be a single digit as well. What should D be equal to? 5. Yeah. So like if you try to move the 2 to the right side, that means 3D would have to end in 5. And so obviously D would be equal to 5. Now we can erase D, just replace it with 5. So replace both D's. And you realize we're just going to keep continuing this until we get the value A. So 5 times 3 would give you 15. Sorry, yeah, 5 times 3 plus 2. Sorry, 5 times 3 plus 2 gives you 17. So it means you have a 1 on top of the C. So that means your next equation would be 3C plus 1 gives you a number that ends in 5. So get rid of the 1, that means 3C would end in 4. So what should C equal to? Someone tell me. Perfect, 8. So 3 times 8 gives you 24. Let's remove the C's. Yep, so now we have to figure out what A and B are. So 8 times 3 gives you 24 plus 1 gives you 25. So it means the 2, we just put it on top of the B right here. Now we have another equation to solve. You see how repetitive this is getting. So 3b plus 2 gives you a number that ends in 8. And if you get rid of 2, that means that should end in 6, which should be equal to. Someone tell me. So 3 times b ends in 6. What's the value of b? If 2. Yeah, so 3 times 2, well, it's exactly 6 anyways. So let's replace b. There you go. Oh, sorry, b is 2. Whoops, my bad. All right, so 2 times 3 is 6. 6 plus 2 gives you 8. We don't have anything to carry now. So it means we have 3a is equal to a number that ends in 2. So someone tell me what a is equal to. Four is correct. Yep. I think someone, yeah, Chengao. I think 26 looks correct. Let me double check that actually. So a is equal to 4. So 3 times 4 gives you 12. So a is 4. Oops, that means to use that pencil. Whatever. So 4 times 3 gives you 12. And we carry the 1 just right here, right there. So we leave it like that. Oh yeah, no, sorry, that's not how multiplication works. Sorry, I'm stupid. So we still carry the 1 up here. 1 times 3 is 3, and then 3 plus 1 gives you 4. So that means this multiplication works. So it means a is 4, b is 2, c is 8, d is 5, e is 7. And if you add those together, just do it really quickly right now in my head. So 2, 8, 10, 19, 26. So your final answer should be 26. And so, Chen Gao, you were correct. Good job. Any questions about this? No questions? All right, let's go back to our slideshow. So now this is the end of part B. Now we're moving on to part C of the Gauss contest. So this is from 2019 contest. Question 21. So in Jen's baseball league, each team plays exactly 6 games against the other teams in the league. If a total of 396 games are played, how many teams are in the league? And I think we're just going to do this together. It'll take you guys a while. So we have each team playing each other against each other 6 times, and there are a total of 396 games that are played. So before we solve that problem, let's try to solve a similar problem, but much simpler. So say we have, let's see, 1, 2, 3, 4, 5 players, okay? Let's say they're competing in a chess tournament. They have to play each other just once, not 6 times. We're just going to assume they play each other once. Can someone tell me how many games are played? So let's say this person, you have to play against him, 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 and him. This person does not have to play the first person again. So he just plays against him, him, and him. I'm assuming they're all male genders, but this guy plays against him and him. And finally, this guy just has to play against him. So how many of these uh, connections are there? Can someone tell me? Like how many games are played? Like in this example. Say if there are 5 players, each of them play 1 chess game with each other. not 15, it's 10. So our first player plays 4 games. So 1, 2, 3, 4. So he just plays against 4 other players. The second person plays 3 other players. He doesn't have to play the first player again. The third person plays against 2 other players. And then the fourth person just plays against the last player, the fifth player. And then this guy already has all his games played, so we don't need to add anything to that. So then this would give us 10. And so what you realize is that we have a sum of consecutive numbers right here. And we can apply this into our actual problem as well. And if you guys don't know what the formula for, if you guys know the Gaussian formula, so Gauss was actually a mathematician, famous mathematician. He actually came up with the formula for the sum of consecutive numbers, and it looks like this. So you have n times n plus 1 divided by 2. That will give you your sum of consecutive numbers. And n is just the number of terms that you want to add. So adding all the terms from 1 to n. And this is your formula right here. So say I substitute 4 into here. Oh, that looks like a 5. See, s still looks like a 5. Whatever, I'm just going to keep it like that. So if you substitute 4, so we have 4 plus times 4 plus 1 would give you 5, divide by 2. And that would give you your value of 10 right there. Right there. All right, so just testing that formula actually works. Now let's try to use it in our actual problem. So we have, let's say we have X number of teams. X teams. And here, instead of them playing 1 game with each other, now they play 6 games with each other. So 6 games with each other. And now what we can do is multiply 6 with this formula right here. So it's because they're not playing 1 game with each other, now they're playing 6 games with each other. So that means there are 6 times more games than if they played 1 game with each other. And we can use this formula just because that we're pairing up people with each other, teams with each other. So like say you have 3 teams, like say you have 5 teams again. Like there would be 6 lines. So pretend like each of these connections have 6 lines in them. So it looks like that. And so that means there are 4 connections right here. So that means you get 6 times 4 in there for the first player. And the second player, the second team, you have 6 times 3. And third one, 6 times 2. Fourth one will be 6 times 1. Here you can factor out the 6. And inside the brackets, you would get the sum of consecutive numbers, which is 4 plus 3 plus 2 plus 1. And so that's why you can use the formula of n times n plus 1 divided by 2 in this example. So we can do 6 times n plus 1. So I just put 6 in the numerator because you can do that for fractions. Divide by 2, and that's a total number of games played. So total number of games played is 396. All right. So that means you have, well, I guess what we could do here is combine these into 3, divide 396 by 3. So now we have n times n plus 1 gives you, what is that divided by 3? 132. Right. And here you're just solving for n. N would be your number, well, not necessarily number of teams. Actually, n plus 1 would be your number of teams. Because because the first player would have like n minus 1 games to play. So basically you're just trying to solve for this right here. And what you should get, I'm not going to solve this equation with the steps. you should get, I think here, n would equal to 11. So you can test out right now. 11 times 12. That would give you 132. So it works. And so total number of teams would be n plus 1, which is 12 teams. And that is your final answer. Any questions about this? No questions? So the reason why, so let's look back at the first example right here, right? So we had n times n plus 1 divided by 2 would be equal to 10. If you solve for n, you would get 4. But in the example, we have 5 teams, not 4 teams. So we just added 1 to the 4. And so it means your number of teams would be n plus 1 and not n. You could do it with, just do another example. We have 3 teams. So if we did the equation, 3 times 4 divided by 2. Whoops. No. Sorry. No, let's not use the equation. So total number of connections here would just be 2 plus 1 is equal to 3. Your n here would be 2. But that's not a total number of teams. So if we substitute 2 into the equation, you get 2 times 3 divided by 2, which is equal to 3. So your total number of teams wouldn't be the n value, it would be the n plus 1 value. So 3 right here. So does that make sense? All right, that's good. Let's move on. Okay, we have 10 minutes left. I think I might have to skip some of the questions at the end because they're going to get hard. These are getting harder and harder. So here's another question from part C. So this 2018 contest, question 23. The smallest positive integer for n, for which n times n plus 1 times n plus 2 is multiple of 5, is n equal to 3. All positive integers n, for which this product is multiple of 5, are listed in increasing order. What is the 2018th integer in this list? And we'll just solve that together. Get a whiteboard up. There you go. All right, so we can try listing out like the first few values of n that work. So the reason why 3 works, so we can substitute into the equation. We have n times n plus 1 times n plus 2. So here's the reason why 3 works. This is just equal to 3 times 4 times 5. From here, we automatically know that this is a multiple of 5 because it has that 5 in the product. We don't have to evaluate what that's equal to. We just have to figure out if there is like that multiple of 5 for one of these terms in here. Say if I did n is equal to like 9. So you have 9 times 10 times 11. And you realize that 10 is multiple 5. So this is just 2 times 5. So that means the entire thing has to be multiple of 5 because it has that factor of 5 inside it already. So that's just another value of n that works. And we can just list out the values of n, like the first values of n that are in this list actually. So we have 3. 3 that works. 4 would also work because it would just be 4 times 5 times 6. We also have 5. Actually, I'm going to list it out in a table. So I'm just going to list the number, so like the term number, and I'll list the value of, that is a bad line. There you go. And I'll list the value of n here. So let's try the first 6 out. Right? So n, remember the question said that our smallest value of n would be start at 3. Next one would be 4. So this 4 times 5 times 6, it has a 5 inside it. The next one would be 5. So n equal to 5. That's obviously going to make a multiple of 5. The fourth one, So 6 wouldn't work. So yeah, 6 times 7 times 8, there's no 5 inside that. If we try 7, 7 times 8 times 9 also does not work. If we try 8, 8 times 9 times 10, 10 is multiple of 5, so therefore the whole thing is a multiple of 5. So 8 will work, so would 9, and so would 10. And if you continue that, the next few terms will give you 13, 14, 15, and so on. And for here, we just need to find a pattern that relates the nth term, like the term number with the value of n. I just list out these last three right here. So 7, 8, 9. All right. So we need to find a pattern to get our 2018th value of n right here. All right, just give me a sec. And I'll just write down the pattern like right now. Basically, the pattern, what you should realize is that to get your value of n, you would divide your term number by 3, and then you also multiply it by 5. I think that should work. Oh, no, not necessarily, but just for the term numbers that are divisible by 3, they would work. So 3, 6, and 9. So those values would work with this formula. So say substitute 9 in here. 9 divided by 3 equals 3. And multiply that by 5 to get you 15. So this formula works with the multiples of 3. But what about the other term numbers right here? What we realize is that we can just, how do we describe this? So say you have a number right before the multiple of 3. So that means that number. So say n divided by 3. Say that number had a remainder of 2. So that means you just subtract 1 from this value right here. And then say if you divide by 3, you get a remainder of 1. Remainder of 1. So that means you get 1, 4, and 7. I'll give you a remainder of 1. If you divide by 3, that means you just subtract this number by 2. Right? So now let's apply that to the 2018th number. So if we do 2018 divided by 3, that should get you a remainder of 2. Someone can double check that for me. Not sure if that's correct. It should give you remainder 2. So like if you see the decimal places like 0.66666, that means that's a remainder of 2. Just going to double check that. Yep, okay. So this would be 672, remainder of 2. All right. And what we do, actually, sorry, I forgot to tell you this. So this number has to round up. So this term number divided by 3, you round it up if it's a decimal. So once you round that up, so 673, multiply that by 5. And since it's a remainder of 2, we just subtract 1 from it. And if you solve for that, just quickly type it in my calculator, you get 3,364. And this is your final answer, right? Are there any questions about this? Sorry if the explanation was like really quick, but we're running a bit out of time, so that's why. Any questions? Anything that I need to clarify? All right, no questions? Okay, I think we're just gonna solve one last problem on the slideshow. So it's out of question 24 and question number 25 right here. So I'll let you guys choose which one you want to solve. So do you guys want to choose this one, question 24, or question 25? You can like unmute yourself if you want to say that, or just type in the chat. Which one you want? 24? Eric wants 24. All right. What about everyone else? I need a majority here. All want 24? I'll do it then. All right. 24 geometry question. All right. Or we're just going to do 24. That's what most people said. Right. Another geometry question. In a diagram here, we have sector ABC is a quarter of a circle with radius of 8. A semicircle with diameter AB, sorry, like these semicircles, diameter AB, so this one, is drawn as shown. A second semicircle with diameter BC is also drawn. Find the area of the shaded region. And on the Gauss contest, they just listed like decimal places. So like they want the closest value to your exact value. But we're going to solve for the exact value because we can. So let's go back to our whiteboard. Right. And I'll try to redraw a diagram. Let's try my best. Oh, that is awful. Okay. Yeah, this is why I was hesitant on teaching geometry to you guys online, because I have to use draw these out, and it's very tedious with online whiteboards. Right, so this was 8. This was also 8. This was part of the shaded region. This is also part of the shaded region. Just gonna do that. All right. So we're just trying to find what the area of the shaded regions are. First thing we're going to do is we're gonna let this shaded region. We're gonna solve each of these shaded regions separately. So we're going to let this shaded region, so the one outside these two semicircles, let that be X. We're going to let the one inside, so the ones overlap the area which the semicircles are overlapping, so that's a shaded region. I'm going to call that Y. Let's write an equation for to relate these areas. So we have the total area. So let's find the total area of this quarter circle. That would just be the area of the entire circle divided by 4. So that means you have pi times 8 squared. 8 squared divided by 4. Well, that would give you, so 8 squared would give you 64 divided by 4 would give you 16 pi. All right, now let's look at the area of each of these semicircles right here. So with diameter 8. So those would have radius 4. So that means we have pi times 4 squared. And since they're a semicircle, so cut in half, we divide that by 2. So that means each of those will have, so 16 squared, sorry, 4 squared gives you 16, divided by 2 gives you 8. So that gives you 8 pi. Now let's find an equation that relates x, y, and these 8 pi values, and 16 pi as well. So we would have the total area, which is 16 pi, is equal to, so we have the area of this two semicircles, we have to add them up. Let's just do 2 times 8 pi, because they're just equal to each other. We also have the area of x that we have to add. Now, if you know your like your union stuff, so you know that y is an overlapping part of these two semicircles. So that means we have to subtract it from the total area. Because if we counted the two semicircles, we counted the area of y twice. So we just subtract it once. And so here you get 16 pi is equal to 16 pi plus x minus y.